Okay, welcome back to Mr. Hassan's Maths channel. I'm answering a question from the June 2014 International A-Level C4 Core Mathematics C34 paper, which is the old specification. We now have P3 and P4. This is a question related to the P3 topic, or P3 specification, and it's to do with numerical methods and iteration. And I'm going through this question specifically because one of the viewers was asking me something related to such a question. So I'm going to explain that part in a bit more detail. Now here we have a function f of x equals 2x cubed plus x minus 10. They've told us that to show that the equation f of x equals 0, so the equation 2x cubed plus x minus 10 equals 0 has a root alpha in the interval 1.52. Now what does this mean here? Well, this is not a coordinate of a point. This is an interval. What this means, this is interval notation. What it means is x is between 1.5 and 2. If you have these square brackets, the equal sign is included. If it was a curved bracket like this, if that was a curved bracket and that was a curved bracket, it would mean 1.5 is less than x is less than 2. If one side is square like this, then there'll be an equal sign with that. Okay, so the square bracket means with the equal sign. So basically it's an inequality. In the interval 1.52, 2, this basically means an inequality. So if you see the word interval and then they have this thing that looks like a coordinate, it's in fact an inequality, and it's between those two values. So we've got to show that this equation has a root in the interval between 1.5 and 2, meaning there's a value of x somewhere between 1.5 and 2, which makes this true. Okay, now if we think about it, just imagine this is the x-axis. A root is a place where a curve or a function crosses the x-axis. Just imagine this function goes like this. Alright, now if there's a root between 1.5 and 2, okay, if there's a root between 1.5 and 2, then that means that when you replace x with 1.5 inside the function f of x equals 2x cubed plus x minus 10, if I replace 1.5 instead of x, it's going to give me a certain value. And when I replace 2 instead of x inside this function, it's going to give me a value with a different sign, because a function has a root where at the point where it crosses the x-axis. Okay, the roots are the places where it crosses the x-axis. So if there's a root somewhere between 1.5 and 2, that means when I replace x with 1.5 and I replace x with 2 inside that function, there will be a change in sign of f of x, meaning it will go from negative to positive, or the other way around depending on how the function looks. But between one point and the other there will be a change in sign, meaning that somewhere between them it has crossed the x-axis. Okay, now that's true for continuous functions, which this is. Sometimes you might have a situation like this where you have an asymptote. Like you might have something like this. There might be an asymptote that exists between these values. So there's going to be a change in sign when I put these two values in, but there's no root because it's an asymptote. But this is a continuous function. It's not one that has asymptotes. So therefore we don't have that problem. So because we can see that it's a continuous function, it doesn't have asymptotes. So if I replace 1.5 inside this function, so I'll have 2 times 1.5 cubed. Two times 1.5 cubed plus 1.5 minus 10. That gives me negative 7 over 4. Negative 7 over 4, which is negative 1.75. And when I replace 2 instead of x, so if I replace the 1.5s here with 2, I get 8. So you can see there's a change in sign. Okay, so you can say as there is, let me try and make my writing a bit neater here. as there is a change in sign in the interval, just try and in the interval between 1.5 and 2. Okay, therefore, okay, there is a root which they've asked us to call alpha, okay, in that interval. What you could also say, as f of x is a continuous function, as I just mentioned, continuous function, so there's no breaks between these values, continues, okay, and as there is a change in sign in the interval between 1.5 and 2, therefore there is a root alpha in that interval. My bad handwriting. In that interval. Okay, so that's part A done. Alright, this is a complete answer for part A. So you can see that when x was 1.5, the y value was minus 1.75. When x was 2, the y value was 8. So it must have passed through the x-axis somewhere between those two values. Okay, that's how you can prove that there's a root between them. Okay, that's 1a done. Now for 1b, it says the only real root of f of x equals 0 is alpha. The iterative formula xn plus 1 equals 5 minus a half xn to the power of a third, where x0 equals 1.5, can be used to find an approximate value for alpha. I'm going to just explain, because sometimes they do ask us for a justification, or they ask us to derive the iterative formula from the original equation. So I'm going to show you how that's done. Okay, just to show you how that's done, in case they did ask you, so they could have well asked us, show that the iterative formula is this. Alright, so what we would do is, we would start off with making this, saying this is equal to 0. So you start off with f of x equals 0, so we'd say 2x cubed plus x minus 10 equals 0. And you can see here that it's quite obvious that it's this x that has been made the subject. One of these x's has been made the subject. It's quite obvious it's this x because you've got a cube root here. So you're going to have to, first of all, say 2x cubed is equal to 10 minus x, adding 10 and subtracting x from both sides, then dividing both sides by 2. If you divide by 2, you get 10 over 2, which is 5, minus x over 2. And then you can say x is equal to the cube root of, which is the same as to the power of a third, a half x n, a half x. That's like that's how you can rearrange it to make this x the subject. And the iterative formula is when to find the next value of x. Okay, so you put a value of x in here. So here we're going to put the first value of x is x0, 1.5. Replace that in here. Okay, and then that gives you the next value of x. And when you replace the answer you've got again in here, like you put, this will be x1, for example. When I put this in here, it will give me x1. Then I put x1 in here, it will give me x2. What will happen is it will get closer and closer and closer to the root. Okay, so that's what we're going to do here. We're going to find first of all x1. So to find x1, what they want us to do is to replace the x in here with x0. That will give us x1, xn plus 1. So the next value of x is equal to 5 minus a half times the present value of x. So when you put x equals 0 in here, x0 is 1.5 in here, that will give us x1. So x1 is going to be 5 minus a half times 1.5. Okay, to the power of a third. Now, what we can do is we can set up our calculator in a way that will help us to just have to press equals each time we want to find the next value of x. Okay, so set it up like this first. Okay, for the first value of x. So this is going to give us x1. So what we do is, to set it up in this way, I want to put 1.5 inside this function. So I'm going to start off up at 1.5 and I'll press equals. Now that 1.5 is now the answer in the calculator. So when I press answer, that's the value that's going to be used for answer. So what I'm going to do is I'm going to set this up now. So I'm going to have bracket 5 minus 1 over 2. Okay, now I'm going to put here times answer. I'm not going to put times 1.5. at the moment, what is in place of answer is 1.5, because when I start, I put 1.5 equals. So that answer is 1.5 at the moment. Then I'm going to put to the power of a third. So I'll put the power of, and I'll put 1/3. That's like the cube root. I could have used the cube root, but I'll just do it the way it's shown. Now, when I press equals, that's going to put 1.5 inside this expression, and it's going to give me the answer. So when I press equals, it gives me 1.619. It says calculate x, 1, 2, and 3, giving you answers to 4 decimal places. So I'm going to write this as 1.619805, and then round it. So 1.619805. 1.619805. Just make sure. Yeah, it continues on like that. So I'll round it to 4 decimal places. If I do it to 4 decimal places, that's going to stop there, sorry. So that's going to give me 1.6198. 6198. Okay, now I've got to put this value back inside this function. Now I'm just going to leave it as x2. Okay, I won't write all this down, and I'll just put the answer down, because the next step for us to do is simply to just, if I press, now you see what has happened now is this is the last answer in my calculator. What I have to do to find x2 is I have to put x1 back into this function. So I have to replace this with this answer. Now, setting up your calculator like this will actually do that for you. When I press equals again, it's going to put the answer that I've got here into this place over there. So pressing equals again will give me the value without having to go through typing it all out again. So I just press equals, and that gives me 1.612159. Okay, 1.612159. 1.612159. Just make sure. Yep. Now I want to round that to 4 decimal places. So that's going to stop there. So it's 1.6122. And then we got to do the same for x3. They want us to find x3, and then we'll be done. So I have to now press this just one more time. Just press this, press equals again, and that will give me x3. So it'll be 1.61264. 1.61264. 1.61264 to 4 decimal places. Okay, that's 6126, yeah. That's equal to 1.6126. Now that gives me x3. So the answer, that's x1, x2, x3. Those are the 3 answers they've asked for in this question. Okay. Now, basically what happens as I keep pressing equals, it's got to get closer and closer. They didn't tell us to do that in this particular part of the question, but the more I press equals, the closer it gets to, it settles down to a particular value, and that gives you basically the root. This is called iteration, a way to get to the root when you cannot solve it easily by factorizing or using any type of formula. All right, so that's part B. Now part C, this is a question where some students were asking, I think, on the channel, how can you show that this is the root correct to 4 decimal places? Okay, now let me just explain this. Basically, how can you justify that this is, by using a suitable interval, that this is the root correct to 4 decimal places? Now, I'm going to just look at the number line. Imagine this is where the root is, somewhere over here. We want to prove that when you find the root, the answer will round to this value, to 4 decimal places. Okay, so if we think about the highest a number can be, so that it rounds to give you this amount, and the lowest it can be when you round it, and it rounds to this amount. So you have 1.6126. If we think about its lower bound, it's going to be 1.61255. If I round this to 4 decimal places, it's going to give me 1.6126. So this is 1.61255. Okay, that's the highest, or you can say that's the lowest it can be, such that when you round it, it rounds to 1.6126. Okay, it rounds to this value. All right, it rounds to this value. Okay, I'm not going to put this exactly there. Okay, I'll leave that like that. Okay, when I round this to 4 decimal places, it becomes 1.6126. And the highest it can be, so it's like this, the lowest it can be, the highest it can be is everything just before 1.61265. Okay, so it's like, this is, you can think of this as 60, and you've got to go 55, and you've got to go up to 65, 1.61265. That's the highest it can, that's just before this value is the highest it can be. When you round something which is just below this value, it's going to round to 1.6126. Okay, so if the root lies anywhere between these two values, when you round it, it will round to this number to 4 decimal places. So for example, if the root falls over here, whatever number that is, it's going to be rounded to give you this. If the root's over here, whatever number it's going to be, it's going to round to this to 4 decimal places. Okay, because that's the lowest something can be, such that it rounds to 4 decimal places to 1.6126, and that is just before this number, just a tiny bit before this number, is the highest it can be, such that when it rounds, when you round it to 4 decimal places, it will round to this value. So if the if the value of alpha, okay, is going to round to this to 4 decimal places, to show that, what we can do is we can substitute f 1.61255 into the function, and we can put f 1.6126 into the function, 265 into the function, sorry. All right, so definitely, there's going to be a change in sign between those two values. There's definitely going to be a change in sign between those two values. Okay, because if the root lies somewhere between these two values, okay, that means it's going to be crossing it somewhere between them. That means, on one side of it, this will definitely give us a different sign from that. If the root lies somewhere between these two, then there will be a change of sign between them because it would have crossed the x-axis. So if we can show that there's a change in sign between these two values, we have shown the root must be equal to this amount, correct to 4 decimal places, because somewhere between these two values there has been a change in sign. Okay, the line has crossed the x-axis somewhere between those two values for sure. Okay, when there's a change in sign between two values, you know that the line has crossed the x-axis, right? So if it has occurred anywhere between these two values, then whatever number it is between those two values will round to this number to 4 decimal places. So I hope that's kind of clear. So let's have a look. We're going to have 2 times 1.61255 cubed plus 1.61255 minus 10. And here we're going to have 2 times 1.61265 cubed plus 1.61265 minus 10. And let's see if that works. So we have 2 times 61255. Get very careful not to make a silly mistake with the typing of your values, plus 1.61255 minus 10. Now that gives us minus 1.17 times 10 to the power of minus 3. I'll write it like that. Minus 1.17 times 10 to the power of minus 3. So that's a negative. And this will give us, I'll write it down here. So I'm going to go back now and change this to, instead of 5565. I'll press equals. And you can see that's now positive. So that's 4.94 times 10 to the power of minus 4. 4.94 times 10 to the power of minus 4. So we can see that this is negative. We can see that f 1.61255 gave us negative 1.17 times 10 to the power of minus 3. And f of 1.61265 gave us positive 4.94 times 10 to the power of minus 4. So we can say, therefore, as f of x is a continuous function. It's always good to write that. Continuous function. There's no breaks in it. And there is a change in sign between f 1.61255 and f 1.61265. Therefore, the root will round to 1.6126 to 4 decimal places. Okay, something like that. As I said, forgive my bad handwriting, but yeah, that's the way it is. So there we have the answer to this question. Okay, so I hope that's clear for those students who were asking this question just yesterday. They were asking me, how can you justify that this is the root corrected 4 decimal places? What do they mean? How does that work? I mean, I hope you understood the reasoning behind it. Okay, that when there's a root between two places, the curve, the line or the function cuts the x-axis between those two places, and if the value where it cuts the x-axis has to be this to 4 decimal places, then that means it has to cut the x-axis somewhere between the lower bound and the upper bound of this value, all right, when it's rounded to 4 decimal places. And how do you find the upper and lower bound? You just basically, this is like 61260, so it's like you do 1.61265 and 1.61255. Okay, and those are the lower and upper bound, and you show that there's a change in sign somewhere between those. Therefore it rounds to 4 decimal places. Okay, so that's question number 1. Okay, I went a bit like off on a tangent here explaining, but I want people to understand, not just answer like parrots. So here we have other questions from this particular paper can be found in the link that will appear over here. Other questions from this topic of numerical methods and iteration from P3, you can find it in this playlist over here, and you can subscribe to my channel by clicking on this link. Don't forget to check out the description for other videos or other material you might find useful. Thank you for watching, and see you soon.